Alrighty, welcome back, boys and girls. It's your main math man, Miss Shane, coming to you live from Summit Academy. And in this video, still working on that Unit 4 system of equations on Lesson 13 now. And it says true or false, we have two lines. So use the lines to decide whether each statement is true or false. So in the first one, it says a solution to 8 equals negative x plus 10 is 2. And so what I want you to do is this. I want you to use yellow. So we're going to plug in, and solve. Or simplify even. So what you can do, plug in 2 into x and see what you get. So we're going to say we have 8 equals negative 2 plus 10. And again, negative 2 plus 10 is going to be 8. So we're going to say since 8 equals 8, this is going to be true. For number 2, it says a solution to 2 equals 2x plus 4 is 8. The same kind of idea, plug it in. So we're going to say plug in 8 into the equation. So we have 2 equals 2 times 8 plus 4. Well, 2 times 8 is going to be 16. So this is going to be 16 plus 4, which is 20. Which is not equal to 2, so we're going to say this one is false. So number 2 is false. For number 3, it says a solution to negative x plus 10 equals 2x plus 4 is 8. So let's find out by plugging it in. So we're saying x equals 8. So let's do orange for this one. So I'm going to say x equals 8. So let's plug it in. So I have negative 8. So negative 8 plus 10 equals 2 times 8 plus 4. And what we can do is we can actually simplify using Desmos. So what I can do is let me pull up Desmos. And let me type in exactly what I had. So I had, let me scoot that down a little bit. So we had negative 8 plus 10 gives us 2. So on the left side is 2. On the right side, however, it's 2 times 8 plus 4. And if you notice how both of these numbers are not the same. So we're going to say these are not equal. So since these two numbers are not equal, we know this is going to be false. I'm going to say false for this one for number 3 as well. So false. False for number 3. For number 4, it says a solution to negative x plus 10 equals 2x plus 4 is 2. And if we actually look, since we're solving for x, we can say, hey, that's going to be the x coordinate in this solution point. And we can also check by plugging in. So we're going to say negative 2 plus 10 equals 2 times 2 plus 4. And so since we can simplify, we can get this. So let's shift back over. So that's going to be on the left side. On the left side is going to be 8. On the right side, we have 4 plus 4, which is also 8. So this is going to be actually true for number 4. Number 4 is true. And then for number 5, it says there are no values of x and y that make y equal negative x plus 10 and y equals 2x plus 4 true at the same time. Well, we know that's false because we look at the point. So let me actually say this is false. Because, so we can say, look at the point 2, 8. It is a solution because it's where those two lines intersect. Again, that got to be careful though, because we're saying when x equals 2, both of those functions, meaning both of those y values, is going to be 8. So it has to be each of those situations. For the next part, it says, here are 3 systems of equations graphed on the coordinate plane. So again, a system of equation, anytime you see that word system, it means more than one. So we're just saying it's more than one equation graphed on the same coordinate plane. So notice how there's 2 lines on a graph in each of those equations. So it has A, B, and C, capital letters. And it says, first part, match each figure, meaning each of the pictures, to each of these systems. And again, I know it's a system because it has that kind of that group, it has that bracket grouping them together. So let's match them together on our coordinate plane. And what I'm going to do is I'm going to say, look at y-intercept. That's always a good place to start because you know that, hey, for this first one, I know I have to start at the point +5. And well, if I look at my options, only one of these goes through that point +5. So I can say, well, if I look at +5, it goes through right there. And if I look at 20, let me actually do in blue for that one. If I do 20, I also have that graph there. You can also look at, if you want to look at the slope as well. So look at slope and be able to tell about, positive versus negative slope. So again, if it was positive, it would be going up and to the right. If it was negative, it would be going down and to the right. So make sure that you're careful on that. So if I looked at these two, or this system of equations, I'd say, well, I have one system that has a positive slope that goes through +5, which is this line here, and I have one that has a negative slope that goes through +20. So I'm going to say for this one, I'm going to match it up, and I'm going to say this one goes with A. So this one I can make a line through since I used it. All right, what about this lowercase b? If I look at some of these options, I can say, well, let's do red and blue. So I have 2 positive slopes, which is the same for both of these. There's 2 positive slopes, but I have one that goes through -10, so let's find -10, which is right there. And I have one that goes through -1, which is about right there. So I can say that this one goes with B, lowercase b. We're just trying to match these pictures with the systems of equations. And so that means process elimination, this one has to be lowercase c. And we also know that because if we look at the y-intercepts, I can say look at 12, it's about right here, and look at 27, again, as your y-intercept. Again, that's on the y-axis. Where does it hit the y-axis at? Well, it hits at 12 and it hits at 27. All right, so I have those matched up for those graphs. And for part 2, for this part, it says find the solution, or for number 2, it says find the solution for each system and check your solution if it's reasonable based on the graph. Well, what I want to do now is I'm going to say this. I'm going to say use Desmos to graph. That way it's easier to solve. So let's do it like this. So let's say, let me re-enable this and let's pull up some of these. So what you want to do, again, change your axes. Notice how I have my picture. So I'm going to say on my x-axis, I need to change it from -25 to +25, and it's counting by steps of not 1 but 5. And then for my y-axis, similar idea, I'm going to say let's go from -25 to +25, counting by steps of 5. That way, our window looks very similar to what we should be doing. And so now I'm going to type in the equations that we have. So we said that A matches with A. So we're going to say like this. We have y equals 3x plus 5 as one equation. And we have we have y equals negative 2x plus 20. Notice how it kind of has a very similar graph. It goes through those main points, but what is our point of intersection? Again, wherever those two lines cross is where it has a solution. So let me write that in. So let me make sure you can still see it. Okay, so I'm going to say, let's say on the side here, key part to remember, point of intersection. That's where the two lines cross. That's where the two lines meet. That's going to mean we have a solution point. So point of intersection is the same thing as a solution point. So for that first one, what do we say we had? Well, we said we had the solution point right here is going to be 3, 14. So make sure you're labeling that on the graph. So let's do the next one and clear out your graph. First equation we have for, let's do C. So since we had C matches with capital B, so it said y equals 0.5x plus 12, and we had y equals 2x plus 27. Find where your graphs meet. So we said, again, capital B matches with lowercase c, and we said that solution point is going to be negative 10, 7. So again, be able to, click on the graph, be able to find it, and be able to label it. So I'm going to say this point down here is going to be negative 10, say negative 10, 7. Right. And then lastly, we have our uppercase C matched with lowercase b. And so we're going to graph that system for lowercase b, which is y equals 2x minus 10 and 4x minus 1. It's a little bit lower graph, so let me actually make sure it's on there. So notice how it's on this point. I can actually highlight that real quick for you too. So it's going to be the point negative 4.5 and negative 19. So let me hide that so that way we can go back to this. And we're going to say this point right here is going to be the point we said negative 4.5 comma negative 19. So again, notice how those points match up with where they would be on the graph. And be sure to pause, rewind as needed. All right, next part after it says your teacher will give you a page, which will all be on their desk, of systems of equations. What I want you to do is, instead of graphing each equation, I want you to graph one. So pick one graph, and I want you to graph it carefully provided on it. So I want you to pick one of those to graph, but I'll give you this first part. So it says describe what the graph system of equations looks like when it has one solution, 0 solutions, or infinitely many solutions. So for this part, I'll write it in. So it's saying we just have one, let me write that a little bit better, one point of intersection is when we have one solution. When we have 0 solutions, that just means that we have parallel lines. What that looks like too, if you're looking at the equations, that means they have the same slope, but different y-intercepts. And then if you have infinitely many solutions, make sure you're remembering, again, that's when it's the same line, where if you want to remember 2, that's 1 on top of each other. So that just means that they are the same exact line, each of those solutions would be the same. So what I want you to do now, do now, if I can actually write it, do now, is pause, pick one system to graph, and have partner do a different graph. So you're going to do one, your partner is going to do another, and you'll be fine. So make sure you pause the video, that way you can try it out. All right, make sure you ask questions if you haven't already on how to graph that. On the back, it looks like this, so some practice problems. It says write the equations for the lines shown. So let's do that first. So I'm going to let's find the black line first. So let's say the black line. I'm looking at the black line, highlight my y-axis, find your y-intercept. My y-intercept is at that point. So let's say y-intercept is positive 2. And if I make my staircase, I can say, well, my change in x is plus 1, and my change in y is plus 3. So I can say my slope, let's say slope is going to be equal to the change in y over the change in x, so change in y over change in x, which means we have 3 over 1. I put those two things together. I have this is going to be m, and this is going to be b. So I can have it in the form y equals mx plus b. Rewrite my equation for the black one is going to be like this. I have y equals 3x plus 2. So that's going to be my black equation. My black line, I should say. For my blue line, very similar setup. We have the information we need. We're going to say, where's the y-intercept? Well, that's going to be at the point 8. So for blue, our y-intercept is equal to 8. Our slope, however, notice how it's going down and to the right. So we're going to say our change in y is going to be minus 3. So we're saying it's minus 3. And our change in x is going to be plus 1. So we're saying for every 1 step to the right, we go 3 steps down. So our slope is going to be negative 3. Put that information together, we have the equation y equals negative 3x plus 8 for our blue equation. All right. So it says, for part B, it says describe how to find the solution to the corresponding system by looking at the graph. Well, that one's real simple. So it says, let's say, how to find it. So let's say find where the two lines intersect. Where they intersect, that's your solution point. On this one, what's our solution point? Well, if we look at where they cross, they should cross right there, and that should be the point 1, 5. So I'm going to say my solution point is 1, 5. So let's label that solution. And it says describe, for part C, it says describe how to find the solution of corresponding system by using the equations. Well, for that one, we set equations equal to each other and solve. All right. So again, make sure remembering a system of equations is at least two equations on the same coordinate plane. For number 2, it says the solution of the system of equations is 5, negative 19. Choose two equations, so we're picking two answers that might make up that system. So let's pull up our wonderful Desmos calculator. So I want you to do this. I want you to graph on Desmos. And I'll show you how to do that. So let's clear that out, pull this up, and let me scroll this down a little bit so that way I can see. Something like that maybe. Shift over, okay. And what I'm gonna do first is I'm gonna change these axes. Actually, this will be fine. I'll leave it how it is. So I'm going to type in this. I have y equals negative 3x minus 6. So once I have that graph, what I have to do is I have to plug in the point and say, okay, is the point 5, comma negative 19, is that on the line? So we're saying, is this point on the line? That's all you're saying. So if it's on the line, it is a solution. If it's not on the line, it's not a solution. So on this one, you can see that, hey, this point negative 5, 5 negative 19, if I'll ever get it right, is not on the line. So we're going to say it is not a solution for that one. So we're going to say no for that one. What about the next part? What about, let me actually change this to a different color. Let's do green. Oh, it's easier to see. All right, so what about the next part? So for that equation B, I have 2x minus 23. Same thing, not on the line, so we're going to say this is not a solution. So we're going to say not a solution, not a solution. How about for C? We have negative 7x plus 16. So notice how I type it in exactly how it is. Notice how that point is on the line. Again, I should be able to drag. Again, I can drag and trace over my line to find any point as a solution. But if I notice, hey, wherever I match up, I can say that point right there, 5, negative 19, is on the line. So I'm going to say this one is a solution. Keep going for part D, or equation D, I should say. I have x minus 17. We're going to say no for that one. So we're going to say no, it is not a solution. And for the last one, we have negative 2x minus 9. That one is a solution. So again, notice how each of those graphs are different, but I can say if that point is on the line, it is a solution. All right. So on the next part, solve system equations. So this is real simple. Graph, still same idea. I'm going to say graph on Desmos. So this will be your turn. Again, give me a solution, or let me say point of intersection. Point of intersection is solution point. Solution point. Again, remember, it should be an ordered pair. is an x value and a y value. So make sure you give me those two things for both number 3 and number 4. So same idea, graph on Desmos, and it's going to be your term. So make sure you can pause, so that way you can try this out. Again, be sure to ask questions if you have any. All right, now that you graphed out number 3, number 4, here's number 5. It says here's an equation, and then it has, for the first part, solve by using the distributive property first. So that's what I'm going to do. So I'm going to do, let's have, I can cancel out 15 divided by 5 is going to be 3, and so this is going to be the same as 3 times x minus 3 equals 3 times 2x minus 3. And so what I can do is that distributive property, have my boxes on the side here, so I can use the space to my benefit. So I have 3 on the outside, so 3, I have 1x, positive 1x, times positive 3 is 3x, and I have positive 3 times negative 3 is going to be negative 9. Same idea with this one. I have positive 3 on the outside, and I have on the inside of my parentheses, I have positive 2x and negative 3 again. So this is going to be positive 6x and negative 9. So I rewrite my equation. I have this becomes 3x minus 9 equals 6x minus 9. So now that you have this equation, we can solve by getting rid of one of the variables on both sides. So we're going to say, all right, which one's lower coefficient, 3x or 6x? Well, I'm going to say I can subtract 3x from both sides. So this is going to be negative 9 equals 3x minus 9. Then I can add 9 to both sides. I'm going to say this is 0 equals 3x, so x equals 0. Then it says for part B, solve without doing the distributive property. So what we can do is I can divide, if I take this equation right here, I can divide both sides by 3. So let's say for here, divide both, let's do an orange. Say divide both sides by 3. So then if I do that, I'm going to have x minus 3 equals 2x minus 3. If I subtract x from both sides, I have negative 3 equals x minus 3, which same idea, add 3 to both sides, get x equals 0. And for the last one, check your solution. We're going to say for this one, graph in Desmos. So in order to do that, let me make that one full screen, unlike the last time. So let me shift this up. So that's what I was talking about when I was on the line. So apologies for that one. And let's do it like this. So I'm going to say, here's my left side of my equation. So I have 15 times x minus 3. And I have divided by 5. And then my other one is going to be 3 times 2x minus 3. Notice how they intersect at one point because there's one solution and we're saying x equals 0 for that one. So make sure you can use the graph to be able to solve your equations. Be sure to ask questions, rewind, replay as needed, and as always, super slam that subscribe button.